All right, so you know how we keep seeing all these incredible AI applications popping up? Ones that can actually do stuff in the real world, like book a flight or order you a pizza by connecting to all these different services and data out there.
Yeah, definitely.
It's pretty mind-blowing, but have you ever stopped to think about how they actually make all those connections work? It seems like every time some cool new AI app comes out, it's got this tangled mess of code behind it just to talk to the internet and databases and all that stuff.
Yeah, it's like they're building a rocket ship with duct tape and paper clips.
Exactly. It's getting so incredibly complex, and it's a real headache for the developers trying to build these things. It's what they call the glue code nightmare.
You're totally right. We're way past the point where we're just impressed by LLMs, large language models just generating text that sounds kind of human.
Right, right.
Now it's all about what these models can actually do.
Right.
How they can interact with the real world, access real-time information, use special tools, and tap into different knowledge bases to solve actual problems.
Yeah, and that brings us to something that could really simplify things. Model Context Protocol, or MCP.
MCP.
Have you heard of this?
Yeah, I've seen it around.
It's being hailed as the USB-C moment for AI, which I thought was a brilliant analogy.
It is. It is.
We've been looking at this YouTube video that really breaks down MCP, how it works, and why it could be a total game changer.
Oh, cool.
So in this deep dive, we're going to try to cut through the hype and give you a clear, practical understanding of what MCP really is and why it's so important for the future of AI development.
Sounds good.
So our goal today is pretty simple. Make this whole thing understandable and relevant for you no matter what your level of expertise is.
Awesome.
So let's take a step back for a minute and think about how AI applications have evolved.
Yeah.
In the beginning, we had these amazing standalone LLMs that were great at understanding language and generating text, but they were kind of isolated, right?
Yeah, they were impressive but limited.
Exactly. Then came this idea of agentic frameworks, which basically meant giving the LLM more freedom to act on its own, using external tools and information to achieve certain goals.
It's like going from a chatbot that can only answer your questions to a digital assistant that can actually book your appointments or order groceries for you.
Okay, so imagine our hypothetical equity research analyst over at Jeffrey wants an AI to create a report comparing NVIDIA and Tesla stock, right?
Okay, laugh.
Now, the AI might have some basic knowledge about those companies from its training data.
Yeah, of course.
But it's not going to have the most up-to-date stock prices or those in-depth analyst reports.
Right.
So to make a truly useful report, one that includes company descriptions, financial figures, summaries of recent news articles, the AI needs to pull data from a bunch of different sources.
Yeah, makes sense.
And in the past, the way they did this was by writing tons of specific custom code, what the video calls glue code.
Glue code?
Yeah, glue code, because it's like gluing the LLM to all these different APIs and data sources. So to get the LLM talking to Yahoo Finance for stock data or accessing a company's internal database or extracting info from PDFs, developers had to write a separate piece of code for every single connection.
Yeah. And that sounds like a recipe for a lot of headaches.
Oh, it's a nightmare. Think about it. You have to spend all this time writing code for each individual connection.
Right.
But here's the real kicker. What happens when one of those external services decides to change its technology? Your carefully crafted integration breaks, and you're back to square one debugging, rewriting code. It's like a never-ending cycle.
Yeah, I see your point. That would be a major pain, especially if you have hundreds or thousands of AI applications all relying on these external services.
Exactly. It's a huge maintenance burden, and it slows down innovation. It's like trying to keep a car running where every single part needs a custom-made replacement.
Yeah, it's not sustainable.
So the big question is, how do you create a more standardized and stable way for these systems to interact? And that's where MCP comes in.
MCP.
Model Context Protocol. It's like establishing a universal language, a common interface that lets LLMs talk to a wide range of services, whether it's tools or knowledge sources, in a consistent and predictable way.
So instead of needing a unique connection method for each external service, they all kind of agree to speak the same language.
Exactly. That's the idea.
That's interesting. So how does that work in practice?
So the idea is that each external service would build what's called an MCP server.
An MCP server.
So for example, Yahoo Finance would create an MCP server that exposes its stock data and financial tools through this standard protocol.
Makes sense.
Google Search could do the same for its web results, and companies could create MCP servers for their own internal knowledge repositories.
Yeah. Okay, I'm starting to see how that could simplify things. But wouldn't you still need some code on the AI application side to manage the whole process?
You're right, you would still need some code on the client side, but the really complex part, or the part where you have to understand and communicate with each individual service, that gets drastically simplified and centralized.
So the burden of integration shifts to the teams responsible for those MCP servers.
Precisely. The Yahoo Finances, the Googles, the internal IT departments, they take on the responsibility of maintaining that standardized connection.
That's a big shift.
It is. So let's get a little more technical and see how this actually works in practice.
Okay, let's do it.
The video uses a great example of a chatbot that needs to interact with both Google Maps and a to-do list app called Todoist.
Okay, so two very different services.
Exactly. So when the chatbot, which acts as the MCP client, starts up, it looks at its configuration to see what MCP servers are available.
Okay.
And for each of those servers, let's say Google Maps, the client sends a standard request called list tools.
List tools.
Yeah, it's basically the chatbot asking Google Maps, hey, what can you do?
Oh, like a capabilities menu.
Exactly. And the Google Maps MCP server responds with a structured list of its capabilities, all described in this standardized format.
And what would that look like?
So, for example, it might say, I have a tool called Search Places that lets you find locations based on a query, and here's how it works, and here's the information I need to make it work.
So it's not just listing the tools, it's also providing instructions on how to use them.
Exactly. And that's crucial because the LLM might not inherently know anything about the Google Maps API, but it can read this standardized description and figure out, okay, if the user wants to find pizza places near them, I can probably use the Search Places tool and extract pizza places as the query.
Yeah, that makes sense. LLMs are surprisingly good at that kind of reasoning.
Right, and the video even showed some code from Anthropic's Python SDK that shows how the client gathers all those tool descriptions from the available servers.
So the AI is essentially building its own standardized toolkit of external capabilities.
Exactly. Now, on the server side, let's say we have a Google Maps MCP server built with TypeScript. It acts as an intermediary. It receives the standardized request from the client, translates it into whatever language the Google Maps API actually uses, gets the response from Google Maps, and then reformats that response back into the standardized MCP format to send back to the client.
So it's kind of like a translator, ensuring that both sides understand each other.
Precisely. And it's important to remember that MCP isn't replacing those existing APIs like the Google Maps API. It's more like building a consistent wrapper around them.
Right.
And there's something called the input schema that's super important for maintaining this standard.
Input schema.
It defines the structure and data types for the parameters of each tool.
Uh-huh.
So for our Search Places tool, the schema would specify that it needs a query parameter, maybe optional latitude and longitude parameters, and the format for each of those, a string for the query numbers for latitude and longitude.
So it's all very specific and structured.
Exactly. And this ensures that communication between the LLM and the server is always predictable and consistent, which reduces errors.
It's like a detailed instruction manual for each tool.
Exactly. Now, beyond just tools, MCP servers can also expose other things like resources and prompts.
Resources and prompts. Tell me more.
So think of resources as providing standardized access to knowledge.
Okay.
So instead of writing custom code, sometime you want to pull data from a specific database or extract info from a PDF.
Right.
An MCP server can expose these as resources, and the MCP client can use a list resources request to see what knowledge is available.
So it's about making knowledge more easily accessible to the LLM.
Exactly. For example, instead of needing a complicated one-off integration to access those company reports stored as PDX on a server, you could have an internal MCP server that exposes them as resources.
And the LLM can search and retrieve information from them in a standardized way.
Right, and this could really help break down information silos within an organization.
That's powerful.
Now, prompts are interesting because they acknowledge that writing effective prompts, the instructions you give to an LLM, is a skill in itself.
Oh, yeah, for sure.
And often it requires expertise related to that specific external service.
Right.
So the idea is that the MCP server developers, the ones who really understand their service, can provide predefined, optimized prompts that AI engineers can use.
So it's like they're sharing their best practices for interacting with the service.
Exactly. The client can use a list prompts request to see what prompts are available, and the video showed a simple example of a summarization prompt that takes a piece of text and a topic and returns a summary.
That's pretty cool. So instead of every developer having to figure out the perfect wording for a prompt, The MCP server can provide one that's known to work well.
Exactly. It simplifies things for everyone.
Hmm.
The video also mentioned a basic fetch tool that demonstrates how an MCP server could expose a function to fetch the content of a website given its URL.
So a very basic but essential function.
Right, and the list tools function would show this fetch tool, and the server would just make a standard web request to get the website content.
Okay, so let's try to bring this all together. What's the key takeaway for our listeners?
The most important thing to understand about MCP is the focus on standardization.
Standardization.
It gives LLMs a standardized way to talk to all these different external capabilities, tools, knowledge resources, even prompts.
And the goal is to reduce the complexity and maintenance work involved in building AI applications that interact with the real world.
Exactly. So that USB-C moment analogy really is spot on. It's about creating a universal interface that makes things easier to connect and integrate.
It's about making things plug and play for AI.
Right, and as the video pointed out, MCP is still pretty new.
Yeah, it's early days.
So while it has a ton of potential, it's still too early to say what the long-term impact will be.
But it's definitely something to watch closely.
Absolutely. We could be seeing the start of a major shift in how AI applications are developed.
It seems like it.
So for our listeners, think about this. How could standardization protocols like MCP affect the pace of AI innovation?
Yeah, that's a great question.
What kind of AI-powered applications could we create if connecting AI to external tools and knowledge was much easier? What new possibilities does this unified interface unlock in your field?
Lots to think about.
Definitely, it's an exciting time to be following AI development.
For sure.
All right, that's it for today's deep dive.
Thanks for having me.
Thanks for listening. See ya.